Okay, welcome back for this. So today we are going to discuss about next problem in our section of solids. So you can see the detailed problem in our description. The problem what we are going to discuss today is a hexagonal pyramid which is being cut by a cutting plane, and then we have to draw the true shape of the particular solid. So here the problem given is a hexagonal pyramid of a side 35 millimeter and the axis is 100 millimeter. Okay, so resting with its base on HP when two of its side is perpendicular to VP. So it is very important. So this is the resting condition of the solid. So this is the simple question of the solid which is being given in my problem. And next part would be given in our cutting plane. You can see here the cutting plane is perpendicular to HP. If it is perpendicular to HP, definitely it will be parallel to VP. Hence, if it is parallel to VP, it can be inclined to VP. So we have discussed earlier. You can see here. So now the cutting plane, you can see if it is a cutting plane, the cutting plane is parallel to horizontal plane and perpendicular to vertical plane, where the plane can cut only the front view. Okay, imagine this is your horizontal plane and this is your vertical plane. Now in this condition, it is now like this. Now the cutting plane is parallel to vertical plane and it is perpendicular to my horizontal plane. Imagine this is my object. Imagine this is my object. Now with this cutting plane, I can cut the object only like this. Hence, I can see the cutting plane only in the top view. So this is what we have discussed in our previous classes as a note. So if it is inclined to vertical plane, the cutting plane will be available in my top view. And similarly, I have to draw the true shape here. So that now, in this case of a problem, I will be having a sectional front view or a sectional elevation. I have a top view and then I have a true shape. So this is what asked me to draw in this particular problem. Where does this cutting plane available? It is 10 mm away from axis. Okay, so according to the question, I have drawn the simple question here. See, my side AF and CD is perpendicular to my reference line, whereas it is perpendicular to my vertical plane. So that I have projected all my points and I have completed the simple question of a hexagonal pyramid. Now let us come to our cutting plane. So the cutting plane is clearly given that it is perpendicular to horizontal plane and inclined to 45 degree to my vertical plane. So to do this, here it is given as a 10 mm away from the axis. So where is the axis in my top view? You can see this is the axis in my top view. Okay, so since it is given as a 10 mm away from my axis, what I have to do is I have to take a 10 millimeter in my compass. I repeat again. What is the value given as it is away from the axis? You take the same value in your compass. You try to draw a circle from your O. See here, I am drawing a circle here using my compass. It should be very light and very thin. Okay. Then what I have given, that cutting plane will be inclined at an angle of 45 degree to vertical plane. You have one concept in case of such kind of a problem. You can see here I have a point, 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 and here I have a point, and here I have a point. You try to draw a tangent line which is inclined at an angle of 45 degree. Okay, now let me tell you how to do that. To do that, what I am going to do is I am going to simply fix any point in my reference line. So these things should be very light and very thin. So after which I am fixing my protector here. Having this as my 0, I am taking a 45 degree. So see, this is my 45 degree. So having my scale which is parallel to this 45 degree line. See here, I am drawing a line which is inclined at 45 degree. Now I will have my scale which is parallel to this 45 degree line, and now I try to draw a tangent line over here. So which is my cutting plane. So this is my cutting plane what I have drawn here. So what I did first, I have drawn a line which is inclined at 45 degree. I made my scale which is parallel to that 45 degree line, and I made a tangent line to that 10 mm circle. See here, from here from here, this point will be 10 mm. So that is what we require. It should be 10 mm away from my axis. So that is what I have done here. So what is happening? The part which is below my cutting plane, the part which is below my cutting plane is getting removed. The part which is below my cutting plane is being removed. So here I can name it as a CP. Here I can name it as a CP. So as per our previous problem what we have discussed, now we have to denote wherever this knife is cutting my object. You can see here my knife is cutting here. So my knife is cutting here. My knife is cutting here, and my knife is cutting here. You should be very careful and you have to identify. Here the knife is cutting at a shorter edge. Here the knife is cutting at a slanter edge. Here the knife is cutting as a B to O slant edge. Here the knife is cutting at B to C shorter edge or base edge. So that is very, very important, because we are going to project this towards my front view and we are going to draw the sectional front view. So that is very, very important. So let us project these points. See here, this is available at A to F. So this is my point A to F. This is my point A to F. This point is available from A to O. Where is A to O? This is my point A to O. So you simply project, which should be perpendicular to my reference line, and I have a point here. Okay. So where is this point available? Where is this point available? This point is available at B to O. Let me come to the last. So where is this point actually available? It is available at B to C. Where is B to C? This is my B to C. So I simply project this point, and here I have a point. Okay. So you just recall what we have seen in our previous problem. If any one of my point is directly in this vertical line, I couldn't project it directly. So what I will be doing, I will bringing that point to the nearest slant edge. So what I am going to do is, see here, I am having a point here. I am going to use my compass, this O as a center, and taking this point to my nearest slant edge. So the point which is available here now is being transmitted to O to C. The point which was available in O to B is now available at O to C. Now what you have to do? You simply project this line towards your O to C. Okay. Actually, where was the point? The point is in O to B. So you just transfer that point to O to B. So before which, let me name here. So this will be my 1, this will be 2, this will be 3, and this will be my 4. Okay, so I am having 4 points. You try to replicate the same point here. See, the point which is available at A to F is called as 1. So that I am going to have this point as a 1 dash. The point available at O to A is called 2. This is point O to A. So this is my 2 dash. The point available to O to B is called as 3. Hence it is called as a 3 dash. The point available at B to C is called as 4. Hence it is called as a 4 dash. So now we have transmitted where else the knife has been cutted. We have transmitted that to our top position. Now let us complete this by converting it to a continuous line. See here. So this portion, okay, this portion. So from 2 to 3, then 3 to 4, 1 to 2, 2 to 3, and 3 to 4. Okay, so this portion is removed over here. So hence all the remaining will be available in my particular object. Okay, so let me darken it. So until that my diagram was very light and very thin. So here you obviously know that here the part is being removed. Hence the visible part will be, the visible part would be only this much. So you be very careful, only up to the knife your part should be visible. So what we have did, we have completed our top view as well as sectional front view. We know obviously that once a part is being cutted, we have to implement with the help of a hatching line. we have to denote with the hatching line. It should be of 45 degree and it should be of uniform gap. It is very, very important. So hatching is very, very important. Okay, so now I have completed my sectional front view. So what is the last part of our diagram is we need to draw the true shape. Okay, so you know that already in our previous classes, to draw a true shape we need an axillary plane which is parallel to my cutting plane. Okay, so here since of the space constraint, what I can do is I can take my axillary plane over here also. It is not a matter. So it is not a wrong. Okay, see here what I am going to do is I am going to fix my scale which is parallel to my cutting plane. I move the same plane over here and I try to draw an axillary plane which is named as X and X dash. I am going to name it as a X and X dash. So as previously we know that what we have to do is, so we have to transfer all the points from here which should be perpendicular to this axillary plane, which has to be perpendicular to this particular plane. So what I am going to do is I am just taking all the points there. Just I am taking all the points there. So you make sure your lines are from your cutting point. Okay, so you make sure that is available from your cutting point. So it is mandatory. It should be very thin and very light. It should be very thin and very light. Okay. Okay. So see here, now I have been transferred all the points towards my axillary to my axillary plane. So now what I have to do is, so in our previous problem what we did, if my cutting plane was at the top, I measured from my reference line to the top view to complete my true shape. Now we go in the reverse direction. Now my cutting plane is at the bottom. So what I have to do, to complete my true shape, I have to measure from my reference line in my front view. Okay, you can see here this point, this line denotes A. The A is available in the reference line itself, so this will be my A. Okay, and similarly you can see here, so this point represents 2. See here, from here I am measuring 2, so I am using my compass and I am having an arc. So this will be my point number 2. Okay, so similarly you can see here I am having point number 3. From here I am measuring point number 3. So this will be my point number 3. And similarly the point number 4 is available in my reference line. So that is very, very important. Now let us try to connect all the points. Now let us try to connect all the points in order to complete our true shape of the problem. Okay, see here. So this is my point number 1. This is point number 2. This is point number 3. And this is point number 4. And don't forget, you have to complete the problem by hatching the true shape. I am going to use a 45 degree line. I am going to use a 45 degree line, and I should have a uniform gap. So these lines should be very light and very thin. Okay, be careful whenever you use this kind of a hatching over here. Okay, so we have to name the parts. So you can write as sectional, front view, and this is my top view, and this is my true shape. So definitely you have to write this. This is very, very important. And you be very careful. You can erase the unnecessary lines which have been drawn to complete your true shape. So So this is the true shape for a sectioned hexagonal pyramid where two of its sides is perpendicular to vertical plane. Okay, thank you.